Assalamu alaikum warahmatullahi wabarakatuh, my dear students. I hope everyone's feeling a-okay. Right, this video is all about what you need to do to study for the finals exam. And it will have basically a little bit of advice at the beginning, topics, what you need to know. And then basically it's a compilation of all the topics, summaries of the topics, and a few exam style questions. Now, I just need to make something very clear. This is not going to be a standalone, okay? So you can't just watch this video and expect that you're going to do well in the exam. You're going to have to do some work, and this is what I'm talking about over here. So in order to study for the grade 8 science exam, you will need to read through the book chapters. Make sure you read through the book chapters, and I'm talking at least 2 or 3 times, okay? So you're reading through your book, you're reading through the notes, the classroom notes, any notes that you would have taken. Make sure you go through those. If you have any exercise sheets that you've been given by your teachers, make sure you go through the exercise sheets, the worksheets, the homework sheets, go through all of that stuff. These are the chapters that are included in the exam, okay? So make sure that you know what's included in the exam. Make sure that you do the end of chapter, assess your understanding. Make sure you do all of those. Make sure that you do the end of chapter assessments as well. So once you do those, you've got a basic understanding. It's still not enough. That's still not enough. But you do have a basic understanding. Then I've got this thing called brain, body, boss. Now, what does that refer to? Use your brain. If you don't understand something, that means you go back and read through it. Use Google if you have to. Go back and read through it again. Go back and read through it the next day if you have to. Translate it if you need to. If you still don't understand it, call a buddy, okay? Call a classmate. Ask them if they can explain it to you. Sometimes it's easier to understand it from someone else. And if you still don't understand it from someone like a classmate, then you can call your parents perhaps, an older brother, an older sister if you have one, or you could even send a message to your teacher. Now I will say this though, if you are sending a message to your teacher, please try and send a message early on. Don't wait the day before the exam. We have families as well. We might not be available to answer you the day before the exam. So please make sure that you send a message well in advance. Ask us well in advance if you're not sure how to solve something. Okay, and finally I will say these videos are useful, so make sure you watch the videos and do the questions. The way you do those videos is you pause it, you answer the questions, and you check the answers as well. And of course I will say that you must go through the revision pack. The revision pack is absolutely essential. It is wonderfully made. It is a fantastic resource, and we've got the answers as well attached to this video. So you should have a copy of the revision pack by now. Your teachers would have put it and uploaded it a while ago. And attached to this email in the description below, you will see the answers. There's a link to the answers to the revision pack. And finally, there are some key skills that you will need to understand. So the key mathematical skills, things like using formula triangles. If you're not sure how to use formula triangles, then go and watch a few YouTube videos on how to do that, okay? That is all from me. Best of luck. Take care.
Hello, assalamu alaikum everybody. Thank you for joining me. We are going to start doing the supplementary practice videos, and I'm going to start with unit 1.2. Now these videos are intended for examination practice. Okay, so let's go. Let's hopefully you've got a pen and paper ready to try and do these questions with me as I go along. So just before we start though, I just want to say I've got a quick word. So these videos are supplementary to your own study. So what does that mean? What does the word supplementary mean? It means they're not standalone. So you don't just rely on these videos and don't look through the book. No, what you need to do is you need to read through the book once, twice, 3 times if you can. So that's how I would study. Read through the units once, twice, 3 times, make your own summary, do the questions, and then watch those videos. Okay, so those videos are supplementary, means addition, okay, extra revision. Your book and your notes are the main source of study, and anything else that the teacher might have given you. And if you need extra help understanding the chapters, please go back and watch the original videos, which I might have posted a while ago. So when we did unit 1.2, that must have been back in March or February. If you need to understand the unit, if you need help understanding the unit, then you need to go back and watch those videos, okay? This is not an extensive explanatory video. This is a video where we do some exam practice questions. Okay, let's go. With that out of the way. So here's a quick question, right? So this is the sort of thing that you might be getting in the exam. What I would like you to do is I'd like you to pause the video, try and do it yourself, obviously, and then unpause the video and do it with me. The SI unit for measuring distance is what? What is the standard international unit for measuring distance? And that is obviously the meter, okay? And the symbol for that is just simply M. There are 1000 watt in a meter. Okay, so the first thing you need to understand is that you need to read the question twice. So here we go. Meter. 1 meter has 100 centimeters. Here's a meter. I've got a meter ruler right here. A meter ruler has 100 centimeters. So, and each centimeter has 10 millimeters. Okay, so a meter ruler has 100 centimeters and each centimeter has 10 millimeters. So if it's got 100 centimeters and 10 millimeters in a centimeter, that means it's got 1000 millimeters. Okay, there are 1000 meters in a kilometer. The word kilo simply means 1000. So you can have kilogram, which means 1000 grams, kilometer, which means 1000 meters, kilobytes, which means 1000 bytes. Kilo just means 1000. An object is in what if its position changes relative to another object? Obviously, it's moving, so that means it's in motion. It's in motion. If the position changes, that means it's in motion. And that's all relative to whoever's watching. I might be standing still or might be sitting down right now, like I look like I'm not moving. But if an alien is watching me from outer space, the Earth is moving, and so am I. The same way, if I'm sitting in a car, I might not be moving relative to somebody sitting next to me. But if somebody's watching the car from the outside and watching the car move, then I look like I'm moving with the car. Okay, the next question says, a watt is a place or object used for comparison to determine if something is in motion. So we just talked about that, a reference point. Reference point. So that is the point of the observer. Once again, I just want to remind you that if you don't understand those concepts, or if you're not sure about them, go back and watch the original video, which you'll find on the YouTube channel, on the YouTube channel page. What is the length of the path between 2 points? Okay, distance. Distance is the length of the path between 2 points. And shortest distance is a straight line, but it doesn't say it's a straight line, it just says is the length of the path between 2 points. Okay, moving on. Okay, so this is once again the kind of question that you might be getting. You've got a graph here and you're asked to analyze the graph. On Saturday, Ashley rode her bicycle to visit Eileen. Eileen's house is directly east of Ashley's. The graph shows how far Ashley was from her house after each minute of her trip. So what you need to do in these kinds of questions is differentiate between the information that you need and the information that you don't need, because there is some information here that you obviously that are not relevant. Is it relevant to know that her name is Ashley? Is it relevant to know that she was on a bicycle? Maybe. Is it relevant to know that she was going to visit her friend's house? So what you need to know is analyze the information and differentiate between what's important and what's not important. Okay, let's go. So the first question says, Ashley rode at a constant speed. What does the word constant speed mean? Constant speed, if you remember, means it's not changing. Okay, constant rate means it's a straight line. It is not changing. The acceleration is constant, i.e. 0. So that's, sorry, the acceleration is non-existent in this case. There is no acceleration because it's constant speed. Ashley rode at a constant speed for the first 4 minutes of her trip. What was her constant speed? Well, let's have a look. So there it is, the first 4 minutes of the trip. So that's the first thing we need to understand. Where's the 4 minutes of the trip? Here it is. This region here, from there all the way to here is 4 minutes. What was her speed? Well, the speed is equal to the rise over the run. The speed is equal to the distance covered over the time taken. That's what speed is. Speed equals distance over time. Or in this case, where's the distance? Here's the distance. Here's the time. What was her constant speed? Well, it's going to be how much? It's going to be 800 minutes, or meters, sorry, per minute. Why? Why is it per minute? Because it says it right here. Now, normally, speed would be meters per second, but over here they've got it in minutes. So we've got 200 meters per minute. Make sure you've got the units right. Now, what if I wanted the speed in seconds, meters per second? What do I have to do? If I wanted the speed in meters per second, all I have to do is change 4 minutes into seconds, which would be 240 seconds. And then I'd have to divide 800 by 240, which gives me something like 3.4 or something. 800 divided by 240, which gives me 3.3 meters per second. Okay, and that would be 3.3 recurring meters per second. Okay, but that's not what we asked for. We just asked for the constant speed. What is the speed? The speed is 800 meters in 4 minutes, which is 200 meters per minute. Or meters per second. Next one, what was her average speed for the entire trip? How do we work that out? For the entire trip. So for the entire trip, it's going to be total distance divided by total time. Okay, the total distance covered divided by the total time it took. What is the total distance? The total distance is up to here. You see it? That's the total distance. So it's 1,600 meters. And what is the total time? The total time is 10 minutes. So it's going to be 160 meters per minute. What was her average velocity for the entire trip? What was her average velocity for the entire trip? Well, remember, this is a bit of a trick question because speed and velocity are closely related, except the only difference is that velocity has a direction because it's a vector, while speed is a scalar. It doesn't have a direction. So let's say, for example, if I'm traveling at 20 meters per second, that is my speed. If I'm traveling at 20 meters per second north, then that is my velocity. Okay, so in this case, what was her average velocity for the entire trip? It's going to be exactly the same, 160 meters per minute, except she lives, Eileen's at east, so it's going to be that, 160 meters per minute east. Ashley stopped to talk with another friend during her trip. How far was she from her house when she stopped? Well, let's see, where was the moment on the graph where Ashley stopped? You can see she's going at a constant speed here, then she stops for a while, then she continues moving. So this is the moment here where she stops between 4 minutes and 8 minutes. So she stops for 4 minutes, doesn't she? 4 minutes. And what was Ashley's instantaneous speed 5 minutes into her trip? What is instantaneous speed? Now remember, we've got average speed, which is the speed for the entire trip. Total time, total distance divided by total time. That's average speed. Then we've got something called instantaneous speed. The word instantaneous means at that instant. So at 5 minutes, exactly 5 minutes, what was her speed? Well, at exactly 5 minutes, her speed was 800 divided by 5. Is that correct? Do you think that was her speed? 800 divided by 5. No, it's not. Because even though it's distance over time, at this moment here, she's not moving. Speed is equal to the gradient. So at this moment here, she's actually not moving, she's stopping. So her speed at that moment is actually 0 meters per second. Okay, so just be careful with that, because if the gradient is flat, that's a terrible way for drawing flat. If the gradient is flat, it means the person is not moving. On a distance time graph, if the gradient or the slope is flat, it means the person is not moving. So at that moment, her speed is 0 meters per second. Okay, let's go, let's do some definitions. What is the average speed? Hopefully by now you know that it's the total distance divided by the total time. That is the average speed. And it's always good practice in the exam to actually just sort of put a slash or a mark on the sentences that you've used up. Velocity. What is velocity? Velocity is speed in a given direction. Okay, speed in a given direction. Now I'm hoping you've already done these. You've paused the video, have already done these, and now you're checking your answers. Okay, if you haven't, please pause the video, do these, and then check your answers with me. What is instantaneous speed? That is speed at a certain point. What is the slope? The slope is the steepness of the line or the gradient. And what is speed? Speed is distance per unit time. Okay? Oops. All right. Next. If the statement is true, write true. If the statement is false, change the underlined words or words to make the statement true. Now, this is a very, very common question in the exam. Okay, the kind of question you might get. On a distance time graph, a speed of 0 would appear as a horizontal line. We've just done that. So it would appear as a horizontal line like that. Let's have a look. Yes, in fact, that's what we got over here. That is a speed of 0. That means they're not moving. And so does it appear as a horizontal line? Yes. So we're going to write true for that one. The SI unit for speed is meters per minute. Not true. The SI unit for speed is actually meters per second. So this one is false. And in fact, it's meters per second. However, meters per minute is a unit of speed. Kilometers per hour is a unit of speed. Miles per day is a unit of speed. Any of those are units of speed. Why? Because simply amount of distance over amount of a certain time. So as long as you say, I've covered 100 kilometers in one day, that is technically a unit of speed. But the standard international one is meters per second. Okay, number 3 says a distance versus time graph will never show a horizontal line. False. We just saw one before. Will never show a horizontal line. That's a bit strange, that one. I don't know how to quite what they actually want. They mean vertical line. Right, yeah, a distance versus time graph will never show a vertical line because a vertical line just means in an instant the speed has or distance has increased. So that's what they mean here. A vertical will never show a vertical line. It can show a horizontal line because that means the person has stopped. Number 4 says the slope of a line is found by multiplying the rise by the run. No, it's dividing the rise by the run. Okay, dividing. That's from maths as well. So if you want to find the slope, if you found the gradient in a distance time graph, that shows you the speed, then it's going to be the rise over the run. Multiplying, and that's dividing. Oops, dividing the rise by the run. That is terrible. Let me write that again. That's better. On a distance versus time graph, a straight line indicates that the object speed is 0. Not necessarily. So it just means that it's constant. So that is once again just means that it's constant, not necessarily 0. So this is constant speed, this is constant speed, that is even constant speed, and this is a constant speed of 0. but it doesn't mean that it's necessarily zero. Only in one of those cases. If it's flat, then it means it's zero. Number six, speed is in a given direction is called velocity. True. Oops. Ah, that's too far low. I should be careful with that because it makes it harder. Right, next. A speedometer shows the what speed of a vehicle. It shows the instantaneous speed. Instantaneous, which means the speed at a certain time. Instantaneous. Sorry. Instantaneous speed. And I think actually that is an A. So it shows the instantaneous speed of the car, which means the speed at that certain point. I don't want the average speed when I'm driving the car. I want to know my speed at that point. Number 8 says to describe an object's motion, you need to know both its speed and what direction. Where is it going as well? Okay, number 9 says the what speed of an object is found by dividing the total distance by the total time. Total distance by total time immediately should always give you the idea that it's average speed. And finally, you've got a question here. Alfonso ran the 1,000 meter race in 2.5 minutes. Alfonso's average speed was what? Meters per minute. Now remember, it's the speed is going to be equal to distance over time. It's 1,000 divided by 2.5 minutes, which means 400 meters per minute. Okay, we'll see you in the next one. Best of luck.
Assalamu alaikum, my dear amazing students. Welcome back. So first and foremost, I have to tell you the same thing I told the grade 11s. I have a new microphone, so hopefully my voice is a little bit clearer, because I know I had a few students tell me my voice wasn't very clear. Hopefully now it's a little bit clearer. Anyway, we are now at unit 1.3. Inshallah, as you know, I said I will be posting videos until we finish all the units for the exam. And then once we're done with the units for the exam, inshallah, we'd also be doing some extra revision, and that'll be that, inshallah. And what I'm going to do at the end as well is I'm going to compile all the videos into one video. Okay, so that'll be a long video, but at least it will be one video for everything that you need to know. Somebody said that that would be easier. We'll see. Okay, let's go. So we've got extra supplementary practice. Let's have a look. So I've got this here that I want to do. What I would like you to do, as always, is I'd like you to pause the video. I'd like you to do it, and then check your answers with me as I go through with it. So in science, what three changes in science, okay, cause an object to accelerate? So this is something that we have talked about in class. We've talked about many times. So inshallah, most of you would get the three changes are basically increase in speed, increase in speed is a form of acceleration. Decrease in speed is also acceleration. Okay, so either speeding up or slowing down, or the last one is changing directions. So all of these are forms of acceleration: changing direction, speeding up, or slowing down. What is the equation for finding the acceleration of an object that is moving in a straight line? Of course, it's going to be acceleration is equal to final velocity or final speed minus initial speed all over time taken. Now some of you might be thinking, what is this? These symbols, they're very difficult. Well, another way to put it is like this: S2 minus S1, final speed minus initial speed over the time taken. Okay, that's all you have to do. And that is the same as this: final speed minus initial speed. Initial just means the beginning, the first speed, all over time. That is acceleration. So acceleration is change in speed, change in velocity. Graph A, velocity of course is speed with direction, just to remind you. Graph A below plots a race car's speed for 5 seconds. What is the car's rate of acceleration? The car's rate of acceleration is going to be change in speed over time. So we know the time is, look, 1, 2, 3, okay, so it's for 5 seconds. Okay, so it goes from 0 to 5 seconds. So this last point here is 5. So that's 5 seconds. We know the time is 5 seconds. What's the first speed? The first speed is 0. What's the final speed? Final speed is, that's 24, 21, 24, so that's 27, that's 30. So it's going to be 30, because this point here is 30, that's 27. So it's going to be 30 minus 0 over, what's the time? 5 seconds. So it's going to be 30 divided by 5, or 6 meters per second squared. That is the unit for acceleration, 6 meters per second squared. Graph B, on the other hand, let's see if I can just zoom in a little bit. Okay, graph B, oh, that's not what I wanted to do. Oh, now it's all over the place. That's very weird. Okay, let's just zoom out again. Graph B, on the other hand, plots the same race car's speed for a different 5 seconds. What is the car's rate of acceleration? Well, I can tell you right now it's 0. Why is it 0? Because there's no change in speed. You see, it starts at 12, it ends at 12. So what's going to happen there is, if we go final speed 0 minus initial speed, final speed 12 minus initial speed 12 equals 0. And divided by 5, 0 divided by 5 equals 0, which means there is no acceleration. There is a speed, but it's constant. It's not changing. So the car is moving at 12 meters per second. But the acceleration is 0. There is no change in speed. The car is just moving at the same speed. Okay? And finally, the definition of acceleration. What is the definition of acceleration? Acceleration is, okay, change in velocity over time. Okay, so the change in velocity over time. Change in speed over time, yeah, okay, officially it's change in velocity. Velocity is speed and direction, and acceleration does have a direction, okay, because it's a vector quantity. So officially it's change in velocity over time. That is the official answer. Okay, let's look at these options over here and see if we can figure out whether they are true or false. This is called modified true or false, which means if it's true, you leave it as it is. If it's false, you have to correct it. First one says, if a train is slowing down, then it is accelerating. Is this true? Yes. Remember, we said acceleration is either slowing down, speeding up, or changing directions. The second one says, to find the acceleration of an object moving in a straight line, you must calculate the change in distance for each unit of time. It's not change of distance, it's change of speed. Remember? Change of speed, not distance. Next, a Ferris wheel, which is this here. Remember, the Ferris wheel is this big thing, and people go on it on theme parks and they look at the whole city. It's in Winter Wonderland, it's in Hawali Park, it's in many places. A Ferris wheel turning at a constant speed of 5 meters per second is not accelerating. Well, it is accelerating. That's actually false. It is accelerating. Why? It's not speeding up, it's not slowing down. It's because it's changing directions. It's like a car going around a roundabout, which means, remember what we said? We said there are 3 conditions for acceleration. Either you slow down, or you speed up, or you change directions. So in the case of a roundabout, a car going around a roundabout, If it's moving in one direction, it's not, and it's moving constant speed, it's not accelerating. But if it's moving around the roundabout, what's going to happen to it? Over here, the direction changed. Now it's moving this way. Over here, the direction changes again. Now it's moving this way. And since the direction is changing, we call that acceleration. Acceleration is either slowing down, speeding up, or changing directions. Right, number 4. An airplane is flying west at 200 kilometers per hour. 2 hours later, it's flying west at 300 kilometers per hour. The average acceleration is 100 kilometers per hour. Is this true? Let's have a look. What is acceleration? Acceleration equals change in velocity. So it's the final speed minus the initial speed all over the time. What was the final speed? Okay. It was 300. What was the initial speed? 200. What was the time? 2 hours. So that means 100 divided by 2 equals 50. So that is false. It is not 100 kilometers per hour squared. It is 50 kilometers per hour squared. Number 5 says a speed versus time graph for a car's motion is a horizontal line at a speed of 12. The car's acceleration during this time is 12. No, it is 0. Why? Let's understand the question first. If you don't understand the question, you won't be able to answer it. Here is a speed versus time. Speed, time. So the speed is 12 and it's a horizontal line. That means the speed is not changing. It's not slowing down. It's not speeding up. So what's happening here is the acceleration is not 12. The acceleration is 0. And we started at 12 and we ended at 12. So then 12 minus 12 divided by time is 0. 12 minus 12 is 0 divided by time is 0. So it's actually false and it's going to be 0. Number 6 says the SI unit for acceleration is kilometers per hour squared. That's also false. This is a unit for acceleration, but this is not the SI unit, not the standard international unit. The standard international unit, as some of you are yelling through the screen, is meters per second squared. Okay. Number 7, the rate at which the velocity of an object changes is the object's rate of, come on, everybody should know this by now. The rate at which the velocity of an object changes is the object's rate of acceleration. Acceleration is change of velocity over time, or the rate of velocity change. An airplane is accelerating at 8 meters per second squared. Each second, its speed increases by 8 meters per second. That's the whole point. Acceleration is change of speed. If it's accelerating at 8 meters per second squared, that means every second it's increasing by 8 meters. If it's decelerating, that means it's slowing down. It's still acceleration, but it's slowing down by 8 meters. Number 9, an airplane is accelerating at negative 8 meters per second. The distance the airplane travels each second is what than the distance it travels during the previous second. So once again, it's going to be 8 meters less than the distance it traveled during the previous second. Because every second it's going 8 meters less. 8 meters less. 8 meters less. So if the plane starts at 1,000 meters per second, which is very, very, very fast, then after 1 second, it would be traveling at 992 meters per second. After 2 seconds, it would be traveling at 984 meters per second, and so on and so forth. Okay? That's what that means. An amusement park ride falls straight down for 4 seconds. Oh, it looks like it's this thing here. Maybe that's what they're talking about. You know, where you sit down on it. I don't know what this is called, but it's scary. I know some of the boys like the scary rides, and some of the girls too. So it falls down for 4 seconds. During this time, the ride accelerates from a speed of 0 to 40. S1, the starter, is 0. S2, the end, equals 40 meters per second. And the time it took to get from here to here is 4 seconds. That's the time. Of course, it's going to ask us to work the acceleration. Acceleration, as we know, equals s2 minus s1 all over the time, which equals 40 minus 0 over 4, which is 10 meters per second squared, which is pretty fast. Okay, so that is almost free fall, really. Oops, oh, that's going to be difficult for me to fix. I don't know how to fix that. What just happened? Okay, I have no idea how I did that. I'm gonna try and oh, that's all it was. Okay, that was cool. I didn't know you could do that. I did not know you could do that. Should we try that one more time? So you're listening to everything I'm saying right now. Wow, you are accurate. That's amazing. Okay. Right. Okay, that's amazing. Right, so the speed is 10 meters per second squared. Anyway, moving on. We're trying to keep this short. Okay, so this is the last thing I want to do. The graph below shows the motion of a runner. What could the runner do to make the slope of the line rise? What could they do? Stop running? No. How could you make the rise go, instead of this, go like this, or go like this? That's what it's asking for. So instead of this, I've got a ruler here, by the way. Another one. Hey, see? Instead of this, I want it to go like this, or like this. Really steep. That means I have to cover more distance in less time. So I have to run faster. So I have to increase my speed, if anything. Increase my speed. D. Number 2, members of the Fairview Track Running Club are running a 5-kilometer race. What is the distance of the race in meters? Okay, this is where we have to do a conversion. 5 kilometers equals 5,000 meters. Okay, 5,000 meters. Number 3 says, what condition is necessary for an object to make a good reference point? Remember when we were talking about reference points? The object is moving at a constant speed. The object is accelerating. The object is fixed relative to the motion you are trying to describe. The object is large. Of course, the object has to be fixed. If it's being used as a reference point, the object has to be fixed. So it's C. Number 4, 2 objects traveling at the same speed have different velocities if they start at different times? No. It doesn't have to be starting at the same time. If I'm traveling at 60 kilometers an hour, and then the next day someone's traveling at 60 kilometers an hour, we have the same velocity. It doesn't mean we don't have to start at the same time. Travel different distances, again, it doesn't matter. If somebody's traveling at 60 kilometers an hour going to Mecca, and somebody's traveling 60 kilometers an hour going to Fahil, they're both going 60 kilometers per hour. Have different masses, once again, that makes no difference, and move in different directions. So they can only have different velocity if they are moving in different directions here, because we said a change in velocity can happen if a person slows down, or speeds up, or changes direction. Number 5, your family is driving to the beach. You travel 200 kilometers in the first 2 hours. Okay, let's do this carefully. 200 kilometers in 2 hours. And then during the next hour you stop for lunch and only travel 25 kilometers. Next hour, 25 kilometers. طيب, what is it asking? What was your average speed? So average speed average equals total distance divided by total time. I hope you remember this. Total distance divided by total time. Oh man, I slaughtered the word time. Which equals, what's the total distance? 225 kilometers. What's the total time? 3 hours. So for those of you good at maths, you should know that that means 75 kilometers per hour. Okay, very good. 75 kilometers per hour. And the last one says, use the graph to answer question 6. Write your answer on a separate sheet of paper. The graph above shows the motion of a person. Describe the motion. Okay, very easy. The person is moving at constant speed. Okay, so they're not actually, because it's distance, time. And they're moving at a constant speed of 1.5 meters per second. And they cover 15 meters in 10 seconds. And then they stop. See, they stop here. And they stop for 10 seconds. That's it. So they are moving at 1.5 meters every second. How do I know it's 1.5 meters every second? 15, rise, overrun, over 10 seconds. So 15 meters divided by 10 seconds equals 1.5 meters per second. And then they are stopping. Here, at 15, they stopped. They are not moving at all. So they stopped moving for 10 seconds. That's it. That's the motion. Okay, thank you very much. We kept it less than 20 minutes. Take care. I'll see you on the next one, inshallah. Okay, assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to another session. And today we are talking about a bit of supplementary practice for Unit 2.1, which talks about nature of forces. Okay, so I'm trying to keep those videos short, so I will jump straight into it so we don't waste any time. Hopefully we'll keep it under 10 minutes, maybe even, maybe 15 minutes. Let's go. Okay, so here we've got a bit of an inquiry warm-up. We've got a prediction to make. If you pull on one end of a skateboard, so here we have a skateboard, okay? And if you pull on one end with a force of 10 newtons, and remember newtons is the unit for forces. So if you're wondering what the unit for force is, it's newtons. And then your partner pulls on the other end with a force of 10 newtons. Okay, what do you think will happen to the skateboard? Well, simply speaking, nothing. It will not move. It will not move. Why is that? Because the forces are balanced. It will not move as the forces are perfectly balanced, which means they cancel each other out. Okay? Hopefully that makes sense. Next, if you pull on one end of the skateboard with a force of 3 newtons, while your partner pulls on the other end with a force of 6 newtons, what do you think will happen now? Well, now it's a different situation. So we've got one person pulling with 6 newtons, while one person is pulling with 3 newtons. Then obviously, we still have an overall of 3 newtons pulling that way. Okay? So now it will go towards the person pulling with 6 newtons. As the net force, remember net force is the overall force, is 3 newtons. So what does that mean? The net force is 3 newtons. Remember, we've got one person who's pulling with 3 and one person who's pulling with 6. Okay, so that means basically it's like this, okay? I want you to imagine it like this. 1, 2, 3, 1, 2, 3, 4, 5, 6. So this will cancel with that, this will cancel with that, this will cancel with that, and we're left with 3 newtons pulling to the left. Okay, so that's what we mean by net force. The overall force that's remaining is going to be 3 newtons. Okay, let's go to number 3. Based on your observations, what can you say about an object at rest pulled in opposite directions by equal forces? It will not move. Not move, as the net force will be 0. It will not move as the net force, the overall force acting on the object, is going to be 0. Right. And then number 4, based on your observations, what can you say about an object at rest pulled in opposite directions by unequal forces? it will move, and to be honest, it will experience acceleration, which means it will experience a change in velocity. It's going to be 0, it will not move, to moving. So if you go from 0 to 1 meters per second, that's still considered acceleration. So if you go from not moving to moving, that is acceleration. So we can say it will move, or we can say it will accelerate. Okay? Same thing. Because acceleration is just change in speed or change in direction. So since it will experience a force, it will experience a change in speed. It will either speed up or slow down or change directions. Okay? Right, let's move on. Calculate. You push on a desk with a force of 120 newtons to the right. Okay, so here's the desk. Back to drawings. You know just how much I love doodling. I've always loved doodling, ever since I was a kid. Okay, so you push to the left. Is that left? No, that's right. So you push on the desk with 120 newtons to the right. Here we go. It is to the right. 120 newtons to the right. And your friend pushes on the same desk with a force of 90 newtons to the left. 90 newtons. What is the net force acting on the desk? Well, obviously, the net force acting on the desk is going to be 120 minus 90, which equals 30 newtons to the right. That's what it's going to be. The 90 is going to cancel with the 90 here, and we're left with 30 newtons. Okay? So 100 minus 90, which equals 30. Which makes sense. Right, next, your friend increases her force on the desk by 30 newtons. So now, instead of 90, she is pushing with 120 as well. What happens to the net force on the desk? Okay, the net force on the desk now is going to be 0 newtons. They cancel each other out because they're exactly the same. They're equal and opposite. Is the desk going to move? Is it going to go from 0 to 1 meters per second or 0 to 2 meters per second? The answer is no, it will not move. So big fat no, it will not move, because the forces are equal and opposite, and there's no net force, or the net force equals 0. Net force equals 0. All right, let's move on. Understanding main ideas. Change in object's motion, blah, blah, blah. Okay, so we need to find out what we need to do first. In the Venn diagram, I hope you're pausing the video and doing it yourself before you're looking at my answers. That's the way you're supposed to be doing this. Remember, you pause the video, you attempt to do it, and then you play it and check your answers with my answers. In the Venn diagram, write the phrases listed below to describe unbalanced forces, balanced forces. Write the characteristics shared by unbalanced forces and balanced forces in the area that overlaps. Okay. Change in an object's motion. That is going to be unbalanced forces. Okay. So what I'm going to do is I'm going to label these as A, B, C, D, E, F, and I'm just going to put them in using letters because I don't have a lot of space here. So change in an object's motion, that is definitely, okay, unbalanced forces, right? Okay. Yeah. So what about push or pull? Push or pull, that's going to be shared. Push or pull. Have a direction. All forces have direction, whether they are balanced or unbalanced. So that's shared as well. Do not change an object's motion. That's going to be balanced forces, as the net force is 0. Net force is 0, that's going to be over here as well. Net force is not equal to 0, that's going to be not equal to 0, it's going to be unbalanced forces. Okay, so I hope you got those right. Let's keep going. Building vocabulary. Now, obviously, once again, I need to remind you, do these before you look at my answers. Otherwise, it's not practice, really. Match each term with its definition by writing the letter of the correct definition in the right column on the line beside the term on the left column. All right, so basically just write the letter over here. Newton. Which one is it? Newton is going to be the SI unit for force, isn't it? So that's going to be A. Force. Which one is force? Some of all forces are acting. It's a push or a pull, so that's going to be C. Number 4. Unbalanced forces will not change an object's motion. Unbalanced forces can change an object's motion. And finally, net force is sum of all forces acting on an object, or the overall force remaining. So that's going to be the answer to that one. Okay, let's move on. And the last sheet, how are we doing with time? We've gone 9 minutes, so not too bad. Hopefully we'll keep it under 15 minutes. If the statement is true, write true. This is the sort of thing you will get in the exam, okay? You'll get that sort of thing where you have to modify the answers, and if it's false, okay? So let's go. My microphone keeps rubbing against my beard, so I'm not sure how clear my voice is. Hopefully it's very clear. Balanced forces do not change the motion of an object. Do we think that's true? In fact, it is true. Balanced forces do not change the motion of an object. Only unbalanced forces do. Forces cause some changes in motion. Some changes? That is false. Forces cause all changes in motion. And that is going to be all. All changes in motion are caused by forces, whether it's change in direction or change in speed. Slowing down, speeding up, or changing in direction requires force. Number 3 says a net force causes no change in an object's motion. Once again, that's false. It causes a change, I guess. If Manuel exerts a force of 10 newtons to push a desk to the right, at the same time Lynn exerts a force of 15 newtons to push a desk to the left, the desk will move to the left. Yes, it's true. It will move to the left, and the overall net force will be 5 newtons. Number 5 says, when you pull on a window shade, you exert a what force? Oh, no, sorry, a force. That's what they want. Okay? A what can be used to represent the direction and strength of a force. So, an arrow. And if you look back, that's what I actually did. Over here, I'm using arrows. Over here, I'm using arrows. So an arrow can be really beneficial in showing how forces behave. So the strength of a force is measured in newtons. Hopefully you remember that. That's the unit. Newtons. And the symbol looks like this, capital N. The net force determines how and if an object will move or accelerate. Yeah. Okay. When two forces act in opposite directions, the object will accelerate in the same direction as the... that's a good one. We've got two forces acting in opposite directions. The object will accelerate in the same direction as which force? This one or this one? It's going to accelerate in the same force as the greater force. The greater. The bigger of the two. The greater force. A force described by what? Sorry, a force is described by its what and by the direction in which it acts. By its magnitude or by its strength. So in physics we call that the size of the force or the magnitude of the force. By its strength or by the direction in which it acts. Okay, hopefully that makes sense. Hopefully that wasn't too hard. I will see you in the next one. And we're live. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. So we are going to talk about friction and gravity, okay? Friction and gravity. So what I want you to do is I want you to get your pen and paper ready. I want you to pause the video, do the questions, and then check your answers. Okay, don't forget to do that. Pause the video, try and solve the problem, solve the questions, and then check your answers with me. So let's go. So here's a list of questions. Pause the video, answer the questions, and then play it. I'm going to obviously just answer it. Name 4 types of friction and give an example of each. The 4 types of friction are, hopefully you remember, sliding, rolling, static, and fluid. And I will just tell you an example of each. So sliding friction is the kind of thing that you experience when you're sliding down the slide, or you're sliding on snow, or you're sliding on the sand, or when 2 objects are just sliding past each other. Even if you're pushing a book on the table, that's sliding friction. So it's only when the object is in motion. It's also called kinetic friction. We also have rolling friction, and that's the sort of friction you experience with wheels. We've got static friction, which is the type of friction that you experience when an object is not moving, but just before it moves. So it's the kind of force that you need the friction force that you need to actually move an object. Okay, and then fluid friction is what you experience when you're moving through a fluid, such as air, gas, or liquid. Okay? B says, classify what type of friction occurs between your bike tires and the ground when you ride over cement, through a puddle, and when you apply your brakes. Okay, so here's your bicycle. Of course, you knew I was going to doodle. I always like doodling. I don't draw very good bikes, but that's okay. I'm working on my bikes. I just keep practicing. That makes me better, right? Just want you to know that as well. If you just keep practicing, you'll get better. You'll get better at anything just by practicing. I promise. See, the wheel is a bit off, so I'm just going to draw a different wheel. Okay? And maybe you can do your own bicycle. And if you want to, you can send me photos of you doodling. Okay? I would love to see some doodling photos. You can send them to me on Teams. Here we go. Here's a bicycle. And so it's moving over the road. Okay. Oh, we can even make this better. We can make it like 3D. Here we go. Right? It's moving over the road. And as it's moving over the road, there was a puddle of water here. So there is a puddle of water as well. Now what kind of friction is it going to experience? Well, it's going to experience rolling friction for sure. Rolling friction. Why is that? Because it's got wheels and the wheels are moving. Okay? The wheels are moving, so therefore it's going to experience rolling friction. What else is it going to experience? It's going through a puddle, and puddles have water, and therefore it's going to experience fluid friction as well. Fluid friction, which is what you experience when you go through water or you go through the air. So generally speaking, since it's moving through the air anyway, it will experience fluid friction. But just to make it obvious, it's going through water, so it's going to experience fluid friction. Okay? Hopefully that makes sense. Let's go. What happens to the gravitational force between 2 objects when their masses are increased? 2 objects. They have gravitational pull between them. All objects do. You have your own gravitational pull. I have my own gravitational pull. This pen has its own gravitational pull. This computer mouse has its own gravitational pull. This coffee cup has its own gravitational pull. Everything that has matter, that is made of matter, has a gravitational pull. The more mass something has, the more gravitational pull it has, the more inertia it has. So mass is a big deal in physics. It's a big deal in our world. Okay? So the more mass, the more gravity. More mass, more gravity. All right? But what about distance? If things are closer together, they act like magnets. If you bring 2 magnets close together, what happens? The closer they are, soon they will just stick together. So this is what happens. Close to it, and then suddenly they stick. That's what magnets do, and this is kind of what happens in reality between objects as well. Now you don't see it. You don't suddenly go next to the wall and you get stuck to the wall because the gravitational pull is so low. You have your own gravitational field, you have your own gravitational pull, but it's very, very, very low. If you want to see it, you have to look at what happens to particles under a microscope, or you have to look at something called Brownian motion. And that is something that is on a much, much smaller scale. So anyway, if you increase the mass, then you increase the gravity, and when you increase the distance, you decrease the gravity. So if the distance is more, then the gravity is less, but if the distance is less, then the gravity is more, right? So more mass or less distance, that means it's inversely proportional to the distance and directly proportional to the mass. So more mass, less distance equals more gravity. Okay? While less mass, more distance equals less gravity. Okay? Relate cause and effect. How are we doing for time? About 7 minutes. That's not too bad. If the mass of Earth is increased, what would happen to your weight? What about your mass? Okay, so here's the Earth, and here's you standing happily on top of the Earth. Now, what happens if we increase the mass of the Earth? What's going to happen to you? Well, let's see. As far as mass is concerned, let's say you have a mass of about 45 kilograms. Okay, so mass of about 45 kilograms. Is the mass going to change? No. Whether you go to outer space, whether you go to the moon, whether the Earth becomes bigger, your mass stays the same. So mass remains the same. Why is that? Because mass is the amount of matter you have. Unless you do a diet or you start eating lots and lots of burgers, your mass is not going to change. Okay, not significantly anyway. So your mass remains the same. But what about your weight? Weight is a force. Weight is a force, and it acts downwards, and it's due to gravity. And weight is actually your mass multiplied by the pull of gravity, so it's mg. So your mass will stay the same, but your weight will change. If you go to the moon, you'll weigh a lot less. If you're on Earth, then your weight is about your mass multiplied by 9.81. If you're in outer space, your weight is 0 because there is no gravitational pull in outer space. Technically there is, but we don't talk about it. So your weight will be 0 in outer space. But in this case, if the mass of the Earth increases, then your weight will increase because the gravitational pull will increase and your weight will increase. Okay. Let's solve these. How are we doing for time? Not too bad. What are the two factors that affect the frictional force between two surfaces? What are the factors that affect frictional force between two surfaces? Okay, so this is one type of surface material, whether it's plastic or glass or metal or wood or rubber. And the second factor is how closely they are pushed together. How closely the surfaces are pushed together. What two factors affect the gravitational force between two objects? Mass and distance. So how much mass they have and how close they are to each other. How does mass differ from weight? Mass is amount of matter. The unit for mass is kilograms. Weight is a force due to gravity, measured in newtons. Okay? Weight is mass multiplied by gravitational pull, and it's measured in newtons. Building vocabulary. Number 4, friction. Which one of those is it? Please take your time, pause the video, and try and solve it. Okay? Number 4, friction. Which one is it? The force which is together, type of friction that occurs. Nope. Force that one occurs. The type of friction that occurs when you that's the one. C. So the force that one surface exerts on another when two surfaces rub against each other. Okay? Rolling friction, that's E. The type of friction that occurs when a wheel turns on the surface. Okay? Sliding friction, the type of friction that occurs when rub sandpaper against wood. I mean, that's an example of it. Number 7, fluid friction, the type of friction that occurs when nope. Okay, so that is B, and then because it says oil is a liquid. Static friction, type of friction that occurs between objects that are not moving, of course. Static means not moving. Number 9, weight. Weight. A measure of the force of gravity on an object. Weight itself is a force, actually. I would argue that gravity is not a force, but weight is. But anyway, gravity, the force that pulls objects towards each other. Okay. So here's the thing. In this book, it says gravity is a force. In the grade 11 book, it says gravity is not a force, but weight is a force caused by gravity. I am more of the idea that gravity is not really a force. So gravity, although it causes a force, it causes weight. Gravity is like a magnet. So, but anyway, for all intents and purposes, for this exam, gravity is a force. Okay? And so is weight. Weight is a force, gravity is a force. Let's move on. How are we doing for time? Nearly there. Write the letter for the correct answer on the line at the left. Right. Number 1. When you swim in a pool, which one is it? Swim in a pool. It's fluid friction. Okay, fluid friction. That was a terrible D. That's better. Number 2. When you rub your palms together, what kind of friction is that? Sliding friction, obviously. You're rubbing them together. Number 3, when you skateboard on a ramp, skateboards have wheels. It is going to be rolling friction. Number 4, when you push a desk that doesn't move. You push a desk that does not move. Which one is it? B. Right. Let's have a look here. What states that the force of gravity acts between all objects in the universe that have mass. So this is called the law of universal gravitation, which has also been labeled as the 4th law of Newton's laws. So there are 3 Newton's laws. Law of inertia, force equals mass times acceleration. For every action, there's an equal or opposite reaction. But for those of you that are nerdy and geeky, the 4th law, kind of like a secret 4th law of motion, is the law of universal gravitation. That's terrible. Universal gravitation. As distance increases, gravitational force decreases. Remember, we said it is inversely proportional to distance. So if the distance is more between objects, then the gravity is less. When you stand on the bathroom scale, it displays the what the Earth is exerting on you? The force? The gravitational force? Or the force is fine. Friction acts in direction opposite to the direction of the motion, which is why it's hard to push things. You push things that are heavy and it's hard. You pull them and it's also hard because friction acts in any way. If you push a desk, let's say you're pushing a heavy desk, it's going to be hard because of friction. But what if you pull it? It's also going to be hard because if you push, then friction is pushing the other way, and if you pull, then friction is pulling the other way. Right, anyway, that's friction for you. Number 9, when the irregularities of one surface come into contact with those of another surface, friction occurs. That is literally the definition of friction. If you're not sure, please watch the video on friction. Remember I said it's about the irregularities of the surface. So even though the surface looks smooth, the irregularities, when they push against each other, they cause friction and heat. Number 10, the applied force required to push something across a surface increases as the friction increases. If there is more friction, then you're going to need more force to push things. Okay, hopefully that makes sense. I'll see you in the next one. Good luck. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to another episode where we talk about supplementary practice for unit 2.3 this time, Newton's laws. So hopefully by now you should know that there are 3 Newton's laws. The first one is called the law of inertia, which means that an object that is moving does not want to stop unless acted upon by external force. An object that is stopping does not want to move unless acted upon by an external force. The second law is force equals mass times acceleration, or acceleration equals force over mass. And the third law is for every action there is an equal and opposite reaction. Okay, let's go. We're trying to keep those under 15 minutes. If you are finding these a little bit difficult, go back and watch the original video where I explained the lesson. So this is not an explanation video. This is more about doing questions. Please make sure that you pause the video, answer the questions, and then check your answers with me. As I said, if you feel like they're a bit difficult, go back and watch the video lesson first before actually attempting the questions. Okay, let's go. So here is a bunch of questions that we have to answer. What is Newton's second law? So we've already answered that. So it's equals force times mass times acceleration, or acceleration equals force over mass. What is the equation? What equation allows you to calculate the force acting on an object? We've already answered that one. So it's force equals mass times acceleration. Or if you prefer, I can write it out so there's no confusion. Multiplied by acceleration. Okay, what is the net force acting on a 2 kilogram skateboard accelerating at 2 meters per second? Well, we know what the force is, so it's 2. F equals, no, we don't know what the force is. That's what we're trying to find out. So force, we don't know. We know what the mass is. The mass equals 2 kilograms. And the acceleration equals 2 meters per second squared. And we know that force equals mass times acceleration. So it's going to be 2 multiplied by 2, or 4 newtons. Easy peasy. That's the answer. Okay. And finally, if the mass of a skateboard is doubled, what happens to the net force? If the mass is doubled, what happens to the net force? Well, it's going to halve. Okay, so, but how do we know that? Well, let's see. Let's take the example we did before. Force equals mass multiplied by acceleration. And if we keep the force exactly the same as they told us, now the mass is going to, what happens to the acceleration of the skateboard? The mass is doubled. So the mass is no longer 2 kilograms, but it's 4 kilograms. Oops, 4 kilograms. Then what is the acceleration? Then the acceleration equals 1, clearly. So obviously, if mass is doubled, the acceleration will be halved. The acceleration will be halved. And this kind of makes sense. Think about it. If you're kicking a ball, a light ball, with a certain force, like as hard as you can, if you kick a light ball, you're going to accelerate it really quickly. However, if you try and kick a ball that is heavy, you're not going to accelerate it as much because it's heavier, because it has a bigger mass. And this is what we're talking about here. So if you double the mass, you're going to have half the acceleration. Okay, let's move on. What is Newton's laws of motion? 2a says identify a dog. A dog pulls on his leash with a 10 Newton force to the left. Identify the reaction force. So this here is about Newton's third law. Okay, if a dog, here is, I'm going to try to attempt to draw a dog. It's terrible, isn't it? Right, so 10 Newtons to the left. What's going to be the reaction force? The reaction force is going to be equal and opposite, so it's 10 Newtons to the right. To the right. Remember, Newton's third law says for every action there is an equal and opposite reaction. So it's equal in size, it's 10 Newtons, and it's to the right. Answer all three. Using all three Newton's laws, explain how objects react to forces. So what they want you to do here is just simply write the laws of motion. So the first one is law of inertia, also known as law of stubbornness. So an object doesn't want to change what it's doing. Does not want to change what it's doing unless acted upon by an, oh, this is going to take ages, external force. I tell you what, I'll use some magic to try and skip forward and see if we can do the next two just like that. Oh, there we go. Just like that. Magic. So now we've got all three. So the first one says law of inertia. An object does not want to change what it's doing. If it's moving, it wants to continue moving. If it's sitting, it wants to continue sitting, unless acted upon by external force, unless forced to do so by something externally. The next one says force equals mass times acceleration, or acceleration equals force over mass. And the third one is for every action there is an equal and opposite reaction. Okay, here we go. Newton's laws of motion. Newton's second law of motion describes the relationship among force, mass, and acceleration. Write the equation. So time and time again you'll see this, and one way of writing this is by doing that. Acceleration. Oh god, this is getting a little bit trickier for me to write on. Equals what? Equals net force all over mass. Okay, acceleration equals net force over mass. Once again, this is the triangle, if you prefer the triangle, because then you can actually work out the different ones. Oh, mass, acceleration. How does diagram to the right illustrate Newton's third law? Well, as you can see, there is an action force and a reaction force from the ball. So Newton's third law says for every action there is an equal and opposite reaction. So what happens here is that the foot is exerting a force on the ball, and equally the ball is exerting a force that is equal and opposite in strength on the foot. Okay, so that's what's happening. So let's say the foot is exerting a force of 10 newtons, then the ball will be exerting a force of 10 newtons in the opposite direction on the foot. So that's all you have to say there, is that there's an equal and opposite force. For every action there is an equal and opposite reaction. So if the foot is exerting a force on the ball, then the ball is exerting an equal force on the foot. Let's have a look here. If the statement is true, write true. If the statement is false, change the underlined words or words to make the statement true. If you increase the force on an object, the acceleration increases. If you increase the force, the acceleration increases. Yes, true. Think of the formula, okay? Force equals mass times acceleration. So if I increase the force, I will increase the acceleration. Makes sense. So that is true. Next one. If you increase the mass of an object, the acceleration decreases. If you increase the mass, the acceleration decreases. Well, it's not worded properly, because do we keep the force the same? So assuming we keep the force the same, let's see. Force, let's say the force equals 4 newtons. The mass equals 2 kilograms. Then the acceleration is going to be 2 meters per second squared. That's just an example, yeah? If you increase the mass of the object, so it goes from 2 to 4 kilograms, and we keep the force exactly the same, okay, then the acceleration will decrease to maintain the force. So if you increase the mass of an object, the acceleration decreases. True. As long as the force is kept the same, then it's true. Number 5 says, to accelerate a 3 kilogram skateboard at 9 meters per second squared, a force of 3 newtons is needed. Once again, force equals mass times acceleration, so it's 3 kilograms multiplied by 9, which is 27. False. False. Because it's not 3 that we need 27 newtons. And finally, number 6, oh no, not finally, the amount of inertia an object has depends on its speed. No, it depends on its mass. Depends on its mass. The more mass you have, the more inertia you have. Write the definition for the terms below. Inertia. So this is an object's resistance to change in motion. And as we described before, we said an object with more mass will have more resistance to change in motion than an object with less mass. How are we doing for time? 11 minutes, not too bad. Let's see if we can answer those ones. Once again, so this is modified true or false. So if the statement is true, write true. If the statement is false, change the underlined word or words to make the statement true. Please make sure you pause the video, answer the questions, and then check your answers. Okay, number 1 says, Newton's first law of motion states that an object will not experience a change in motion unless acted upon by a balanced force. No, that is false. Not a balanced force, but an unbalanced force, which means an external force. If they are balanced, it won't make a change. So it is unbalanced, the answer here. To increase acceleration of an object, you reduce its mass or increase the force applied. Yes, if it has less mass, or if you increase the force, then it will accelerate more. Newton's third law states that if one object exerts a force on another object, then the second object exerts a force of equal strength in the same direction. No, equal and opposite. Opposite. Number 4 says, what is the resistance to change in motion? Called stasis. No, it's not. It's called inertia. Okay, so that's false as well. Action and reaction forces acting in opposite directions do cancel out because they act on different objects. Do not cancel out because they act on different objects. So if they did act on the same object, they would cancel out. But since they act on different objects, they don't cancel out. And it's like the example we saw before with the foot and the ball. The foot acts on the ball, but the ball acts on the foot, so they don't cancel out. So false. They don't. Number 6, if you lean against the wall pushes back on you with a weaker force. Equal. Once again, that's a false. It has to be equal and opposite, so with not a weaker force, but an equal force. Newton's third law. Number 7, Newton's second law of motion states that an object's acceleration depends on its what? On its mass and the net force acting on it. Acceleration is measured in meters per second squared. Force is measured in units called newtons. And the smaller the mass of an object, the what its inertia, the smaller its inertia. Remember, bigger mass, bigger inertia. Okay. Anyway, hopefully that's clear. See you in the next one. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back, and today we are talking about supplementary practice for unit 4.1, which is to do with energy. What is energy? Let's go. Let's give it a go. Let's get it done. Okay. So the first question asks us to identify what are the two different types of energies. Hopefully by now you know that there are two different types of energy, and those are kinetic and potential. Kinetic refers to the moving energy, while potential refers to the stored energy. That means it can be stored, right? So things like chemical energy, things like gravitational potential energy, elastic energy, those things can be stored and we call them potential, right? While kinetic energy is moving energy, and turns out there are a lot of things that we think of as being independent but are actually part of kinetic energy, things like temperature. So thermal energy is an example of kinetic energy. But if you're not sure, please go back and watch the video on energy. That will explain a lot better. This video is not about explanation, it's about answering questions. Please make sure you pause the video, answer the questions, and then check your answers. But if you're still not sure, as I said, go back and watch the original lesson, video lesson, please. Okay, so identify the energy an object has due to its motion. Let's have a look. The first one, what are the different two types of energy? We already talked about that. The energy an object has due to its motion is called kinetic or potential energy. Stored energy, so that's going to be kinetic due to its motion, because they said motion, and motion means movement. Stored energy that results from position or shape of an object is called potential. Okay, so stored energy from the position or the shape of an object is called potential energy. What are the two factors that affect an object's kinetic energy? Well, kinetic energy, as we know, is, here we go, kinetic energy, or also, as I like to write it, energy K, which means kinetic energy, is equal to half times the mass times velocity squared. So the two factors that affect it is mass and velocity. Mass and velocity. So if you just write mass and velocity, that's correct. Mass and velocity. Okay? Applying concepts. What type of energy does a cup sitting on a table have, and why? So here's the table. Oh, this is tricky to write on this. Here's a cup. So this cup obviously has some energy. How much energy does it have? Well, it depends on how high the table is. Why does it depend on that? Because the type of energy it has is called gravitational potential energy, also known as GPE, gravitational potential energy. And the formula for gravitational potential energy is mass times gravity times height, also known as weight, times, let's just capitalize that, weight times height. And weight is actually mass times gravity, your mass multiplied by gravity. But anyway, so we won't worry about that just for now. So what type of energy does it have? It has gravitational potential energy because it has height, because it's sitting high up on the table. The more high it is sitting, the higher up it's sitting, the more energy, gravitational potential energy it's going to have. Okay, so an object falling from the third floor is going to have more gravitational potential energy than an object falling from the first floor. Okay? Okay, let's do some questions. How are work and energy related? Well, turns out work is transfer of energy. In other words, work and energy are very closely related. They have the same unit. They're both measured in joules. And if this is what I always tell my students. If you see work, then just assume we're talking about energy. If you see energy, then assume we're talking about work. They are very closely related to each other. Work is the amount of energy transfer. So it's basically more or less the same as far as we're concerned. What is the power related to? How is power related to energy? So power equals energy or work done over time. That's how they're related. It's the rate at which energy or work is done. That's what power is. So it's energy over time. And another way of writing this is by drawing the triangle. So power, energy, time. Okay. What are the two basic kinds of energy? We've already talked about that. So it's either potential or kinetic. Kinetic. Right. A girl who weighs 30 kilograms, well, that's already wrong, who has a mass of 30 kilograms, because weight is in newtons, who weighs 30 kilograms is in line skating at a speed of 5 meters per second. What is the girl's kinetic energy? Well, we know that the formula for kinetic energy, I'm going to use symbols here. Energy kinetic equals half times the mass times the velocity squared. So knowing that, do we have the mass? Yes, it's 30 kilograms. So it's going to be half times 30 times 5 squared, which is equal to 25 multiplied by 15, which is equal to 375 joules. Now that's the main thing as well, is that once you find the answer, you really have to have the units. 375 joules. And the symbol for joules is a capital J. Okay? That's supposed to be a tick. Right, a hat that weighs 5 newtons, that's better, is hanging from a hook 1.5 meters above the floor. How much gravitational potential energy does it have? So once again, we already said that G P E, gravitational potential energy, is equal to weight multiplied by height. Do we have the weight? Yes, 5 newtons. Do we have the height? Yes, 1.5. So that equals 7.5 joules. That's the answer. Okay. Hopefully that wasn't too hard. And now we've got some sort of matching energy. We have to match each term with its definition by writing the letter. Okay. Energy is, which one of those? Potential energy related to the ability to do work or cause change? Absolutely. That's energy. Kinetic energy, that's the energy an object has due to its motion. No thanks. Okay. Here we go. Potential energy. That's the energy that's stored energy. First of all, stored energy that's due to an object's shape or position. Gravitational potential energy has to do with height. So that's A. And finally, Just through process of elimination, it's going to be C, but let's read through that anyway. So energy associated with objects that can be compressed or stretched. Absolutely. Okay, let's move on. Write the letter of the correct answer in the line on the line on the left. The kinetic energy of an object is equal to 1/2 of its mass. 1/2 of its mass, yes, multiplied by its speed squared. Now I just want to point out something. If it says write the letter, then you write the letter. If it says underline, you underline. If it says you circle, you circle. If it says tick, you tick. Try and be consistent and be accurate with the way you answer your questions. Okay, next, number 2 says the gravitational potential energy of an object is equal to its weight multiplied by its height. So I'm circling it, but I'm also adhering to the rules by actually writing the letter. Number 3 says energy is the ability to do work or cause change. We could not cause any change or do work without energy. If you're finding this lesson a little bit tricky and difficult, please go back and watch the original video, okay? Which I will leave in the description below. Number 4 says energy and work are measured in joules. Okay, fill in the blank to complete each statement. When you do work on an object, some of your energy is transferred to that object. Oops, what did I do? It's transferred double R. I think it's one R. Transferred. I think it is double R. Power is the rate at which energy is transferred. Once again, isn't it? Potential energy results from what? From the shape or position of an object. Shape. A stretched rubber band has elastic potential energy. A change in the object's speed has a what effect on its kinetic energy than a change in its mass? It has a bigger effect. A change in its speed has a bigger effect, and the reason for that is the formula. So half mv squared. You see velocity, it gets squared. So if you double the velocity, you're actually quadrupling the amount of energy because of the squared. So it has a bigger effect. And then once again, if you don't understand that, please go back and watch the original video. It explains all of that. A mountain climber at the peak has gravitational potential energy, has a lot of gravitational potential energy. How are we doing for time? I think we're quite good this time. Gravitational potential energy, also known as GPE. Okay, thank you so much. Hopefully you understood that as well. See you in the next one. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to another exciting session. And today we are going to be doing forms of energy. So that's unit 4.2. We're nearly there. We just have one more unit to go and then we'll be done with our extra exam supplementary revision. And what I plan to do afterwards is compile all of them together. As always though, I will say please have your pen and paper ready because I will be answering those questions and the expectation is that you do them before I answer them. So please do them before I answer them. And if you're not sure, go back and watch the original video lesson. Okay, so the video lesson is going to be the place where you find the explanations and the extensive answers that you will not be finding in this video. This video is all about doing exam style questions. Okay, moving on. How can you determine an object's mechanical energy? By adding, so this thing here, it's actually quite simple. It's simply by adding. Let's see if I can use that. Hopefully, yes. So it is by adding. Oh, it's not working. Why isn't it working? Let's have a go again. By adding both its kinetic and potential energies. Ooh, that's horrible. I was trying to see if I could do that on the pad. Let me see if I can do it a different way. What two forms of energy associated with particles that make up objects? Okay, so there are 5 types of energies associated with particles that make up objects, and those are nuclear, electrical, thermal, chemical, and electromagnetic. So I'll just write all of them. So let me try and do it neatly this time. Oh, no, that's not going to work, is it? Okay. I'm not sure if it's me. Nuclear, electrical, that's also associated with particles. Thermal, oh God, thermal, chemical, and electromagnetic, which simply means light. Electromagnetic. Okay, next we have this exercise over here. Match each illustration with the correct form energy by writing the letter next to it. So we have a stove here. What kind of energy is associated with the stove? Quite a few. So we've got electrical energy, B. We also definitely have thermal energy. That's the job of the stove, C. What else do we have associated with it? Have we got chemical energy? We could have some chemical energy, especially if it's running off gas. We might have some chemical energy. And do we have electromagnetic energy, F? So you'll see a bit of light as well, won't you? So that's F as well. I don't like this kind of question. And I just want you to know, you don't have to worry about this kind of question being in the exam, because we'll be a lot more decisive picking questions for the exam. This one has a bit of, it's one of those things where there's a lot more going on. So I mean here, even with this one here, there's a bit of mechanical energy for sure, because it's kinetic and potential. But you could also argue that there's a bit of thermal energy when she applies the brakes. Yeah, see, that's what I mean. Over here we've got electrical energy, we've got thermal energy, we've got a bit of electromagnetic energy, and we also have some mechanical energy, because when you push it down there's a spring, so that holds some energy, so that's potential. Yeah, that one's got electrical energy as well as heat, thermal energy mostly, and of course electromagnetic, because obviously it's light. So electrical, thermal, and electromagnetic. The sun, interesting. The sun definitely has nuclear energy. The sun has thermal energy, C, and the sun has electromagnetic energy. What about matches? Matches have chemical energy. When you light them, they have a lot of heat, a lot of electromagnetic energy. I think we're good here. Oops. The funny thing is, you could even argue that chemical energy is a form of potential energy, it's a form of mechanical energy. Yeah, see, I don't like this question because it's got a whole lot of combinations. It's a bit wishy-washy. It's not very decisive, it's not very clear. But anyway, as long as you understand that electromagnetic energy means light energy, and potential energy means stored energy, while kinetic energy means moving energy. Let's keep going. Write the letter of the correct answer in the line on the left, at the left. To find an object's mechanical energy, you add its, so hopefully most of you know this by now, you add its kinetic and potential energies. A. 2. A form of energy not associated with particles of objects is what? Not associated with particles. So we're talking about mechanical energy here. That's not associated with particles. There are 5 types of energies associated with particles, and mechanical energy is not one of them. Okay. Number 3, nuclear fusion reactions. Nuclear fusion reactions occur on the sun. Fission occurs here on Earth, but we haven't managed fusion yet. Fusion is pretty interesting though. It produces 4 to 10 times more energy than fission. We haven't managed it yet. The total potential and kinetic energy of the particles of an object is its mechanical energy. D. Okay, isn't it? The total potential and kinetic energy associated of the particle of an object. Wait. Yeah. Okay, let's move on. Mechanical energy is associated with motion, position, or shape. Motion, position, or shape. Electromagnetic energy travels through space in forms of waves. We're talking about light here, and light travels through space in forms of waves. Okay, lightning is a form of what energy? So it's electrical as well as electromagnetic. So you can write electrical, but also, as the name suggests, it's also electromagnetic or light. That's what the EM stands for, electromagnetic. The breaking of what bonds in food releases energy for your food use. I hope you remember this from term 1. Remember we said that energy stored in the bonds. So the energy stored in the bonds is a form of chemical energy. And of course we have 2 types of bonds that we talked about. We talked about covalent and ionic bonds, and both of those store energy. So once you break the bonds, you release the energy, and if you are forming bonds, you are storing energy. So the breaking of chemical bonds, chemical bonds in foods release energy for your body to use. The what of the temperature of an object, the lower the thermal energy. The lower the temperature. The lower the temperature, the lower the thermal energy. Electrical energy is the energy of electrical charges. The electrons, basically. Remember we talked about electrons? We said electrons, these little tiny subatomic particles surrounding the nucleus in clouds. All right, well, that's all. Hopefully that wasn't too challenging. Once again, I'd just like to remind you, if you found this challenging, please go back and watch the original video lesson. Thank you. See you in the next one. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to another session, and today we are recording the very last of the supplementary sessions for the grade 8 exam. What I'm going to do after this is I'm going to compile all the videos into one video. It's going to be slightly long, so it's going to be about 2 hours, maybe 2.5 hours, but I've been asked by many students to try and do that. So instead of having multiple videos, I'm going to have one main video. Now, as always, I will ask that you please try and answer the questions before I do. Here we go. We're going to try and keep this under 15 minutes as well. We should be able to. Okay, so we're talking about energy transformations. And the first question, we've got a juggler. We've got a person who's juggling a ball. And we're asked to say if the statement is going to be true or if the statement is going to be false. And if it's going to be false, we basically change the answer to what makes it true, right? So here we've got a ball that's being juggled up in the air and then back down again. Now, from what we know, at this highest point, the ball has a lot of gravitational potential energy. So I'm just going to do a quick explanation. As I said before, these are not explanation videos. So if you need more explanation, you go back to the original video, please. But at this point here, the ball has a lot of gravitational potential energy, right? A lot of it at that point there. And as it's falling down, over here it's got a lot of kinetic energy, and over here it has a lot of kinetic energy as well. But at the highest point, it has most gravitational potential energy. Anyway, so the first statement says an energy transformation is occurring only at point 3. No, that is absolutely false. An energy transformation is occurring everywhere, at all points. How is it occurring at all points? But at every point, there's something happening. Either it's going from gravitational potential to kinetic, or from kinetic to gravitational potential. As it's going through the air, there's also a bit of heat as well. So there's energy transformations happening all the time. In this example, the law of conservation of energy states or says that the ball never loses kinetic energy. Never loses kinetic energy. This is also false. The reason for that is the ball never loses energy, but it does lose kinetic energy. There is a difference there. So the ball will always maintain its total amount of energy. Energy before equals energy after. However, some of the energy before might be gravitational potential energy. Some of the energy before might be kinetic energy. Some of the energy before might be chemical energy. The energy after might be something else, but the total energy is the same. So a quick example of that is like saying, for example, I've got 10 Kuwaiti dinars. That is equivalent to roughly 30 American dollars. So if I say I had 10 dinars, then I traveled to the States, and now I have $30. I don't have any Kuwaiti dinars left, but I still have $30, which is the total amount of energy I had before. The total amount of currency is still the same. Okay, so that's what we mean. Energy before equals energy after, but it doesn't necessarily have to be the same form of energy. Okay. Number 3, as the ball rises from point 1 to point 3, it slows down. That is true. It slows down because the energy goes from kinetic to potential. The ball has the most potential energy at point 3. That is also true. The most gravitational potential energy is at point 3. Number 5 says the ball has the most kinetic energy as it leaves point 2. As it leaves point 2. No, that is false. It has the most. False. It has the most kinetic energy as it leaves point 1. Okay. Write a definition for each of these terms in the lines below. Energy transformation. Energy transformation. So when energy changes from one form to another. That's what energy transformation is. The law of conservation of energy. Now you really need to know that one. Okay, you really need to know that one, and you need to be aware of it. Okay, this is a very important law in physics. Law of conservation of energy simply states that energy cannot be created or destroyed. Okay, energy can't be created or destroyed. It can only be transformed from one form to another. So I can change it from one form to another, but I cannot make it or destroy it. Next, fill in the blanks to complete each statement. All forms of energy can be transformed. Can be transformed. Okay? All forms of energy can be transformed to other forms of energy. Number 2 says a change from one form of energy to another is called an energy transformation or energy transfer. Energy transformation. So transformation is when something changes to something else. When you use a match to light a candle, multiple transformations of energy occur. Multiple transformations of energy occur. And next one says, the law of what of energy tells how much energy is present after electromagnetic energy changes to sound. Okay, so the law of conservation of energy. Okay, the law of conservation of energy tells us how much energy is present after electromagnetic energy changes to sound. Number 5 says whenever a moving object experiences friction, some of its kinetic energy is changed into heat or thermal. Anytime two objects are rubbing with each other, you experience thermal energy. And if you're finding this a little bit challenging, please go back and watch the video lesson on this chapter. Your body changes chemical energy into what energy when you walk up the stairs? Kinetic. Hopefully you remember that, because of course as the body starts moving, it changes the chemical energy from the food or the fat that you've got stored in your body into kinetic energy or moving energy. Write the letter of the correct answer in the line on the left. Fusion reaction in the sun change nuclear energy into electromagnetic, which is light. Okay, hopefully you remember that electromagnetic energy equals light energy. Okay, electromagnetic energy, electromagnetic. Oh my God, that's horrible handwriting. Sorry. Electromagnetic, or EM, is light. Okay. In a pendulum, a continuous change occurs between kinetic energy and potential energy. It goes from gravitational potential at this point down to kinetic at this point, back to gravitational potential at this point, and then back to, and so on and so forth. Number 9, a baseball in play has its lowest gravitational potential energy when it's in contact with the bat, when it hits the ground, because then there's no height when it hits the ground. And finally, energy can neither be destroyed nor created. The only entity that is able to create is God. And with that, we are done, basically. Hopefully you didn't find that too challenging. What I'm going to do is I'm going to compile all of these videos together. Best of luck for the exam. All the best.